In the previous lecture, we discussed unique pointers as formal parameters, and in this lecture, we're going to discuss how we can return unique pointers from functions. Alright, so I still have the entity class because we have the destructor printout, and of course we don't get that with the fundamental types, and I still include the memory file for the smart pointers. I still have this print function which as a formal parameter has a R-value reference to a unique pointer entity, which as before will do the toString, which will simply print out the member as before, otherwise it will print out null pointer. Next, for this demonstration, I also have this UPTR entity factory, UPTR entity for unique pointer entity. Now, of course, you can call this function whatever you want. This is just a demonstration. So what's the goal with this function? Well, we want to create and return a unique entity pointer that manages an entity. And that is why I called it factory here deliberately, because if you see this in the documentation and you don't know what that is, right, that's why I decided to cover it here. So when you think of a factory, it produces something, it creates something, right? So again, I could have called this function make or get or instantiate unique pointer entity, but instead I chose factory here because again, you could come across that in documentation. Now, a factory is basically a function that will create, or in other words, instantiate a class and return that. So as you can see here, we create or instantiate unique pointer, pass in entity because we want that unique pointer to manage a type of entity on the heap. And I just call it UPTR here for unique pointer. And then of course we construct that. So I do new entity P, a formal parameter int P, and I pass in P right here for the construction of that heap object. And then we simply return that a unique pointer. You can see this function returns this type right here, unique pointer entity. Again, it's a good idea to qualify your smart pointers to the standard namespace because let's say later on you or some other programmer removes this user namespace standard at the top of the file, then you won't have any issues because you have qualified those unique pointers in this function. So basically we have this function unique pointer entity factory that is going to create unique pointers that will manage entities. In the main function, I invoke this print function and I pass in this function invocation here, unique pointer entity factory, and I pass in this argument 55 for the construction. Alright, it will construct that unique pointer, return it right here. That is going to be an R value, and that is going to get passed to the print function, which will print it out. Build and run that, and you can see that works fine. Of course, you can also call a function on the temporary object that this function will return. For example, now the statement is not very handy. It's going to construct a temporary object to the toString function, so it's going to print that out, and then that temporary object is going to get destroyed. Build and run that. Prints out 55, we get entity destructor invoked before we get the end of program. Similarly, we can use this to construct a unique pointer. Whichever way you want, you can initialize using the braces like this, or you can use the equals, the assignment style like this. This is going to return a temporary unique pointer object just like the makeUnique function. I'll do unique pointer entity toString and this will work fine. Next, let's say we have a statement like this, so I do unique pointer entity and I do the assignment, and then I do this unique pointer entity factory. Okay, that is going to create a unique pointer entity and return that. So as an exercise, I'd like you to try and run this and see if this works. Will this actually build and run? As an exercise, I'd like you to think about this statement. From what we've learned so far about the unique pointer, will this build and run? And then also, why does it compile or not compile? I'd like you to do some research, do some thinking, maybe write some code. It doesn't have to be this exact example that I'm showing you. Maybe write something else. Of course, I tend to use the abstract entity class as an example, but you can do something else. And again, just think about what we are doing in this statement. Will this actually build and run? And if so, why? Otherwise, why not? Okay, go ahead, pause the video, try this exercise, and when I come back, I'll show you a few more things in Visual Studio. Okay, welcome back, and of course, back in main here, this will build and run, so I'll just build and run that, and you'll see that it'll build and run just fine. The first unique pointer entity toString is going to print out 55. Then we get entity destructor invoked, and then 22. Then we get end of program, and then we get entity destructor invoked. And if you're still having trouble with this, maybe take a second to think about why this is, what's going on. If you can't quite figure it out just yet, don't worry about it. I'll add these two statements in here just for debugging purposes. So we have the toString before we have the assignment, and then we do the assignment, and then we are following the assignment, we will do the toString again. Scrolling back up to this function, unique pointer entity factory, pause the video for a second as a bonus exercise and think about how we can improve this function right here based on what we've discussed in previous lectures. I'll just continue and I'll go and delete that line right there. In the return statement, I'll use the makeUnique helper function, and of course that again returns a unique pointer. Now if you reflect on some of the previous lessons where we discussed R-value references, move constructors and move assignment operators, what is happening here, and especially with the statement right here where we assign whatever this function returns to unique pointer entity, should be familiar to you. What we will get is an implicit move operation. So in the statement right here where we assign whatever this returns to the unique pointer entity, you might be thinking, wait a minute, doesn't that use the copy assignment operator? And of course with the unique pointer, that is a deleted operator. Well, actually no, if you think about it for a second, we are not using the copy assignment operator, we are using the move assignment operator. And actually you can sort of see that, so I'll do Control-K, Control-I on that operator. And you can see the formal parameter here is going to take in, so the right-hand operand is going to be of type R-value reference to unique pointer entity. You can see right here, this is the assignment operator, right? So we have the move assignment operator. Before we move on, I'll just build around this so we can see that this works. So build around that. We see we get the first toString and it's going to print out 55. Then we do this assignment statement and then something interesting happens here. The entity destructor is invoked. It's going to allocate the object on the heap that stores the value 55. Of course, that entity has an integer member that stores 55, so that entity is destroyed now. Then following that assignment, we get 22 now. Then we get end of program, and then we get entity destructor invoked. So in other words, when program execution reaches the closing brace of the main function, that unique pointer entity is going to get destroyed, and of course it now manages the new object on the heap, which stores 22 in its member, and of course because it manages that object on the heap, it's going to allocate that object on the heap, so we get entity destructor invoked. Next, again, we are really not concerned about the implementation of the unique pointer, but I'll just go to the definition. This is going to be a useful skill for you going forward to look at what you have available. So what operators are overloaded, what constructors do you have available, what functions do you have available, and so forth. Sometimes documentation is quite lacking and it may take you quite some time to actually get to that in the first place. So what you do is you open the file, whether it's a header file or in this case the memory file. And that's especially true for something like game development in Unreal Engine. You open up the header file and you look at what is available to you, right? For example, we can see that we have one operator here, the assignment operator. I'll do Control F for find and I'll click next here. So I'll just do find next. So we have another overloaded assignment operator right here. Of course, we have another one that is deleted, but in this case, we have one that accepts an R-value reference. And what you do when you inspect these files to look at what you have available is you are not trying to, or basically concerning yourself too much about how things are implemented. You just want to look at the headlines. Basically, it's almost like reading the headlines in a newspaper to find what you are looking for. Again, as a beginner, there's a difficult balance. You are trying to figure out what's going on, how things work. But sometimes that's a kind of worms that you should avoid, because if you look at the file or look at the implementation of something, it can be easy to get intimidated. And you are like, what are these macros? What do they do? And then they use helper functions and they use classes and so forth. But you should try and look at it from a high level. So here what we can see is we have an R-value reference with this overloaded assignment operator, so we know that this is a move assignment operator. And from a C++ understanding, this is easy to read. Again, we are not concerned with all of these macros. We are not concerned with what's going on in all of this code. What we can see, however, is this does a simple check right here to make sure that this object is not the same as the right-hand operand. And if so, it's going to do the reset function and so forth. So without getting into the detail, we can see that this function is going to deallocate the object that is currently on the heap, and of course it's going to basically move the heap object from the R-value reference over to the left-hand operand, or in other words to this object. Now again, we are not really concerned about how it does all of that. Based from our testing and based from what we can see here on a high level, we understand how this function works, and that we do have a move assignment operator. Even though the copy constructor and the copy assignment operator are deleted, we do have the move assignment operator available.